Project goals and requirements. Here is a list of requirements that were set by us and by the stakeholder. We first needed to make a data scraper web application, which essentially scrapes tables from different data sets and different input types. And this web application needs to be deployed to HDAP. There are four key functionalities. The application would need to take in four different input types and output as a CSV file. It needs to take in the form, API, HTML, and PDF. For and lastly, it needs to have a job tracking and download link page where the job tracker shows the status of each job and history of the jobs. And attached to that, it has a downloadable link where users can press a link and download the CSV file. Team roles and responsibilities. We had 6 members in total: Alan, Hongyu, Kanishka, Sege, Tommy, and Zahid Zaman. Our roles range from quality assurance to developer to project manager. And the listed responsibilities are the main ones that we were responsible for. But we did work together in a lot of the documentation and a lot of the different projects as well as a team.
According to healthit.gov, in the recent years, almost 86% physicians have adopted electronic health record to collect, store, and transfer patient data. The most commonly used media for electronic health record are PDF files, digital forms, remote database, and cloud platforms, which is why the tech giants like Microsoft, Amazon, and Google have come forward to develop a viable and interoperable solution. On the top right corner, as you can see, an example of how Google Cloud extract data from PDF forms. It can do that quite well from horizontally aligned field. However, when it comes to vertically aligned field, it lacks in accuracy. On top of that, it comes with a cost. Standard Python libraries have almost the same performance and the same issues. We went to a big organization in like CDC to talk to their data scientists, and we found out in some cases they use manual data ingestion approach for their sensitive data, and which that takes them longer time and results in less accurate research. And for that reason, in our project, we made an attempt to address this issue.
Final Gantt chart. We started this project early September and ending in early December. We started with the requirement and research team sprint 2, moved on to design phase, moved on to environment setup with setting up all the boilerplates, then to front end implementation and coding. And after this step, we moved on to the baseline, then documentation and final cleanup. At the end of each implementation and coding team sprints, we made sure to do stakeholder review, testing, and deployment.
This is the architecture of our application. The user will choose the type of passing job and submit a form with essential information such as input file or input URL, etc. Then our application will create a script job object and save the uploaded file into local storage. Then a passing job will start to run, and the job will first fetch the data, either it's a local file or other data from external websites, and then pass the data into CSV files. Each of the CSV file will represent one table or form from the input. The user can download the zipped CSV files from the job detail page. For more information, we also maintain a detailed architecture design document which explains the workflow and include a class diagram.
The UX design and flow of our application is as depicted here. On the home page, we have the 4 data parsing method buttons. Clicking on each one will take you to its corresponding page. In the 4 data parsing pages, the user can input their data source and convert it to CSV. Once Convert CSV is clicked, the user will be taken to the job detail page. In the job detail page, the user can see the job type, file name, and start and end time. They can download the CSV if the parsing was successful. Also, on the navbar, we have the history button. Clicking on it will take you to the job history page. And from here, if you click on the job ID, it will also take you to the job detail page.
I will be showing you
the API to start off. Here I need to enter a URL. Here I have this API URL, which is a fire patient resources. I could choose either flat or structured, but here I just keep it flat for now. The job is done. I can download my CSV files. After unzipping that, this is the converted CSV. Basically, it's the API resources is converted into CSV file. Okay, let's move on. PDF. Now I need to select and upload a PDF file. In this case, it's this PDF file here. This file is provided by our project mentor from CDC. The file is from CDC. It consists for different tables across different pages, and for each table we will create a CSV file respectively. Now let's convert it. Job is done. Let's download this. So in this folder, it consists 4 different CSVs, which correspond to 4 different tables in that PDF file. So basically, you can see our application is able to consume tables, not just from the perfect black, white, like gray 2-dimensional grid table, but also this imperfectly table that you have to be able to recognize in human eyes. Let's welcome Alan.
Thanks, Hongyu. Now let's move on. Next, I'll demonstrate the form parser. So the form parser will take a PDF file and convert the form from it. The difference between the form parser and the PDF parser is that PDF parser takes a generic PDF file, which any table or form is acceptable, while form parser has a parsing template behind that's specifically developed for a type of form. For example, here we have a human infection with COVID-19 report form, and you can choose others, and we have 2 placeholders here. Now let's take one form. So this is a form that we have filled some information inside. Let's try this one. If we want to compare the result with the one passed by PDF parser, the PDF parser generates 5 subtables from the input. And let's compare the result with the first subtable. So I open the result side by side. Above is the one from the form parser, and this is the result from the PDF parser. This is the source code, and this is a CSV file. And we can see that the result from the form parser is more structured and more accurate. Keep in mind that developing a parsing template can take extra time, but for the quality of the result, it worth the effort. And the last parser is the HTML parser. This parser takes a URL and converts all the tables inside the web page into CSV files. In this demo, I will use this page as an input. It has some HTML tables here. So let's copy the URL and let's parse it. Cool. Let's open the result. So the parsing result contains 4 subtables, which is one-to-one mapped to the tables here. So I'm opening the first subtable, and we can see actually the results are quite close to the actual table on the web page. It is also worth mentioning that we have a page that keeps a history of all the parsing jobs. Users can come back to their own jobs and download the parsed result again if needed.
So with the finished project, we have future plans for other teams to continue the work. And here are some things they could work on: is add authentication and login, include additional features for importing data, such as allowing the users to choose their own file name when saving, make form parsing more robust by including ML. There's a Google API that does form parsing pretty well. Add a notification service for users, for example, an email server, and make HTML API parsing more dynamic.